Hello and welcome to this film about metals. It's the second in a series of films about standard level bonding. Hopefully by the time you've got here you know how to spot what type of bonding there will be in a substance, and hopefully by the end of this film you'll understand why it is that metals tend to form positive ions and how this fact actually helps us explain why they have the structure that they do. And we'll then use this structure to explain a few of their physical properties. Okay, what are the metals? Well, I suppose when we ask that question, we're asking what properties do they have and where are they? So where are they? Well, they're to the left of this line, okay? So there's our stairway to boron again. This is all the metals over here, okay? I haven't circled all of them there, but that's where they are. Now, the fact that they're over that side of the periodic table means that their electron shells are closer to being empty than they are to being full, which means that they tend to lose electrons to become stable. Now, if that's the case, then we might expect their atoms, when they're all together, to have lost electrons. And when we talk about the structure of a metal, we should be very precise about saying that it's not atoms in a lattice, but metal ions in a lattice. Okay, so when we're talking about metallic bonding, we need to be able to be clear about the fact that we've got a regular lattice of metal ions surrounded by a sea of delocalized electrons. So these are the electrons that the metals have lost from their outer shells, and they're able to just roam around this structure. So that's what the structure looks like. Let's see if we can use that structure to help us explain some of their properties. Well, why are metals malleable? It's important we are clear about what malleable means. A malleable material is one whose shape can be changed without breaking it. Okay, so if we think about what's going to happen to a metal if we place it under stress, if we try and move one layer of ions with respect to the other. Okay, so we've shifted some of the ions with respect to the ions nearby. Now, is that going to cause the bonds to break? Well, the bonding comes about as a result of this attraction between the delocalized electrons and the metal ions. And because the electrons are free to move around, they're not attached to any particular ion anymore, this bonding will still exist. In other words, these bonds won't be broken by moving one set of ions with respect to another, because the electrons will just be able to move and continue to attract. So that explains why metals are malleable. Explaining why they conduct not only electricity but also heat is possibly a bit simpler than explaining their malleability, because all we need to refer to here is the fact that the electrons are free to move. In other words, they're delocalized. What exactly do we mean by delocalized electrons? Well, they're electrons that aren't confined to one particular atom. Okay, so because these electrons can flow from one end of the metal to the other, they can conduct a current, and because they can kind of form this kind of Mexican wave that moves the kinetic energy from one end of the metal to another, they can also conduct heat very well. And this diagram here, I think, is supposed to be showing the malleability of metals. Okay, so quite a short film. Some very important information to remember there. Okay, quite a lot of people lose a lot of marks in the bonding topic just because they never bothered to remember a few simple facts. Okay, but hopefully we're clear about why metals form positive ions and why that fact is related to the structure of a metallic lattice. And we can use the structure of a metallic lattice to explain the physical properties of a typical metal. If you've got any questions or comments, then as always, feel free to comment on YouTube or to come and find me and talk to me about it.